We are looking at how to solve equations again, and we're going to see an important idea. I think it's pretty intuitive. Okay, so this is fancy math language, but here's the idea. Suppose I have a balance, and it's telling me that 3x equals 9. Well, doesn't it make sense if you've got this perfectly balanced, couldn't you add numbers to both sides and it would continue to be balanced? Or you could subtract numbers from both sides and it would continue to be balanced? Well, what we're talking about today is, what if we multiplied both sides by 2, doubled it? Well, it would still be balanced. Or even divided both sides by 2. You had 6 kilograms over here or something, you cut that to 3, you did the same to the other side, it should remain balanced. And so the point here is simply that. We can add, subtract, multiply, and divide. As long as we do it to both sides of the equation, it's going to continue to remain balanced. Now, another way I like to think about this, and I think it's an important idea to understand how factoring or how algebra works. Suppose I had this. This is factored, so I have 5 times x. So I know that these two factors, these two numbers multiplied together make 25. Well, this is a pretty easy game. You could see that that number has got to be 5. But if you weren't sure, what you could do is you could divide both sides by 5. Now, I think in order to understand solving equations, factoring is a really big part of that. So we could see that, okay, I can't guess the number. All I'd have to do is divide 5 away from both sides. Now, the ones they've given us here don't work perfectly, but this is the same idea. This is factored. I've got two numbers being multiplied. They equal negative 27. Well, I'm allowed to divide on one side as long as I do it on the other. Now, they gave us ones that aren't going to reduce perfectly, which I'm not sure is a great idea, but we get x would then be negative 27 over 5. Now, that number is not intuitive to me. I'm not sure exactly, what it would be naturally, but that's still a number. And our equation is still balanced. So we could do the same here. We're dividing both sides by 3 because we're allowed. This is being multiplied, so I could undo it. I could divide it. So two numbers multiplied together, two factors, make negative 41. Okay, well, what is it? Well, if I don't intuitively know it, I can just divide both sides. So y is going to be negative 41 over 3. Okay, same here. 4 times z equals negative 55. So this is balanced. I'm going to divide one side by 4 to get rid of it. They're opposites. It wants to be multiplied. I'm going to divide. So I do it to the other side to keep it balanced. So z is negative 55 over 4. Okay, so it works the same way. Two numbers being divided equal negative 44. Well, I can just divide. If this is in balance, I'm going to just multiply both sides. You see, this would be opposites. I'm doing the opposite here, so they would be gone. I'd have negative 14 times negative 7, which I don't know off the top of my head. So I get, now it was two negatives, so I get a positive 98. Alright, same again. This teeter-totter is in a perfect balance, and I have two numbers being divided, so I'm going to multiply. But if you do it to one side to keep the teeter-totter balanced, you got to do it to the other. So on the left, I've cleared all of that off of there. And I had two negatives over on the right, so I'm going to get 294. Okay, I'm going to multiply both sides by negative 6. And I get b is 144. Okay, now don't let this one trick you here. This is negative n, but it's really negative 1n equals 9. So we're going to put a number in front of there so it makes sense that we would want to divide away. I want just n. Well, negative 1 is being multiplied by n. Now I want to get n by itself, or I want to divide this side by -1. I've got to do it to the other. Well, those are opposites. I'm left with n is -9. So same here. This is really like a -1k. You don't have to show it. I just want you to understand that there's really a number there. I'm going to divide it away from one side. I got to do it to the other to keep it balanced. K is -8. 8 divided by -1 is -8. Okay, same here. You're just going to divide both sides. You're going to get, it's just going to change the sign of the other. Okay, now with fractions, you really are doing the rules of fractions. You really are doing the same thing. You're dividing both sides by 3/4. Just because it's a fraction, that doesn't change anything. So you would do the same thing. And over here on the right, this is now a number divided by a fraction. So you would keep the top, change it to multiplication, and flip it upside down. But the trick I want to show you here, this is keep, change, flip when you divide a fraction. But if you start with a fraction over here on the left, basically what always happens is you could just multiply by that fraction turned upside down. It's easier to think of it like this than the keep, change, flip, I think. It's the same thing because that's what keep, change, flip is doing. So I'm just going to divide both sides by 4/3. Do you remember you can reduce this down? 3 and 12 would reduce, and you'd have x is 16. Okay, so you really are just dividing a number on both sides, but because it's a fraction, I'm going to multiply it as if it's upside down. But if you do it to one side, you've got to do it to the other to keep that in equilibrium. The left, all this cancels. Over here, I could reduce a 2 and a 14 to make it 7. And I would get this. Okay, same again. I'm going to multiply by the upside down fraction. Can reduce that down. Everything over here is going to cancel. Got y is 18. Okay, now they put it on the other side, but don't let this trouble you. It doesn't change anything. So I don't know if I was going to work it that way or switch around. I think I'll just leave it over here. Now I'm going to multiply by the same number turned upside down. So -5/4 times -4/5, that would cancel. They're the same number turned upside down, but if I do it to one side, I'm going to do it to the other. Now reduce everything over here. So now you multiply the tops, -1 times 2 over 3. And over here you can cancel everything out, including the two negatives would cancel. And you're going to have x is 2/3. Now it's the wrong way, but that doesn't change anything. Okay, we're going to do the same here. I'm going to multiply both sides by -5/4. Oops, I made it as an x instead of, I'm going to just leave it. I changed my z to an x, but same thing. Okay, real quick, let's just get rid of everything over here. They're all opposites, including those negatives. Over here I can, I thought I could reduce. I can't do that, but I can do this. Okay, so I have 1 times 9. There was a negative out front, and 4 times 5 is 20. Yeah, I think we should be doing this with simpler numbers to get started with, but okay, I've just flipped that upside down. Now everything over here is going to cancel except the r. You cancel the 3, and the 6 reduces to 2. Now with fractions, you multiply the top times the top, so I've got -5 over 16 equals r. Okay, now we've got to do some cleaning up. I've got kind of two stories on how to explain this, but I think, for now anyway, I'm going to stick to this one. So there are always three steps that will solve any equation. The first is clean up the rooms. So you got a room on the right and you got a room on the left. We're going to do any mathematical operations, any like terms, anything we can do, we're going to work that till the rooms are as clean as they can be. Then you're going to get the variable back together, and I'm not sure if we're going to see that yet. But suppose y was in the room on the right, Andy was in the room on the left. We got to fix that because we're never going to get y by himself if he's in both rooms. And lastly here, we got to get him alone, which means we just want the y all by himself, or whatever the variable is. So we have some cleanup we can do here. This three-step process will always get you through. So the room on the left is not clean. I'm going to tidy that up. These are the same kind of thing. They can go together. And I get -9. Now over here I've got a whole bunch of y's, but they are like terms. I have 12 y's, -4 y's, -5 y's. They're the same thing. So I'm going to put those together. Yeah, just make sure I got that right. And we get down to this. Okay, well, we've cleaned up. Now we've got to get the variable back together, I should have said. Now he's not in both rooms. I'm sure we'll see that in later videos, if not in this one. So he's not in both rooms, so we're okay. Now get him alone. Well, we saw that they want to be multiplied. This is two factors, two numbers that multiply together to be -9. Well, if we don't know it, we would divide both sides by 3. So we'd have y by himself. And you get y is -3. Okay, I'd love it if you pause it and try this, but I'll start working it here. So I'm cleaning up the room on the left until it's as clean as can be. Now I'm going to clean up the room on the right, and once again, actually it's the same answer. Okay, so I get 3c. Now two numbers multiplied together, 3 and something, make -9. Well, what is it? Well, if we're not sure, we just divide away the 3. So I cleaned up. I would then check to see if C is in the same room put back together, but he is. He's not in both rooms. And finally, I get him alone. Okay, I'd love it. Pause the video, try this. We're going to clean up the room on the left, we get -4. We're going to clean up the room on the right, we get 7c. Okay, now we've got the rooms clean. X is only in one room, which is what we want. So now we get him alone. Two numbers multiplied together equal -4, so we'll divide both sides by 7. So I don't know what that is. It's going to be a fraction, so I divide both sides by 7. Those are gone, and x will be -4/7. Okay, now we're moving to some more complicated cleaning up. Now we learned this is the distributive property, and the 4 is going to own that negative sign. So I'm going to send a -4 through. So -4 is going to go to A, -4 is going to go, and 3 owns that sign. So if you send that through, it's +12 equals 25. Now the room on the left is clean. These are not like terms. I cannot put them together. And the room on the right is fine. Nothing else to join there. So the way we want to get rid of this is I want to get down to the factor. I like it when 4 times something equals some number. I want it to be like this. I want to work with factors. But the +12 is keeping me from being able to work with factors. So I'm going to get it down to this simple puzzle where two numbers are factors that multiply together. Well, I can't. So what I'm going to do is fix that. I'm going to get rid of the 12 first. So by doing that, I have now got it as two factors equal some number. Well, that's a real easy puzzle to solve. Just divide both sides by -4, and you've got it. Now you can move that minus right out front. It doesn't change anything. So A is -13/4. Okay, so we're going to clean up, get them back together, and then get them alone. Well, there's a lot of cleanup to do here. So I'm going to send a -4 through. And when negative 4 goes to negative 2, it becomes plus 8. Okay, I did one step, but there's more cleanup to do. I've got 8 and negative 8, so I'm going to make it negative 4q equals 24. Now, I have this down to factors, which is what I want. I've got one number multiplied times another. Those are two factors multiplied together to make 24. All right, but I don't know the number off the top of my head, so I'm going to just divide both sides by negative 4, which I'm allowed to do. The negative 4's cancel, and I get q is negative 6. So we cleaned up the rooms. Then the q was in one room, so I didn't need step 2. Then I got him alone. Okay, we're going to do the same cleanup here. I'd love it if you try it. They keep making this real easy. Okay, I'm sending negative 6 through there. I get this. Now this room is still not clean. There's more work to be done. I can put 12 and negative 12 together because they're the same kind of thing. Now this is what I want. Well, so R is not in both rooms, so I'm clean. R is not in both rooms, so I don't have to worry about that. Now let's get him alone. Well, I've got what I want where I have two numbers multiplied. I have two factors, which is really helpful. This is the most basic way to solve these, the most basic puzzle. So I like it like this. I'm going to divide both sides by negative 6. And I get R as negative 5. Okay, so what we saw today is that this balance beam is super important. And as long as you do something to one side of the balance beam and do it to the other, everything will be fine. So we can add to one side as long as we do it to the other. We can subtract, we can multiply, divide. You just have to do it to both sides. And I think we'll see more of this in the next video. But to solve any equation, no matter how complicated, the first thing that we do is we clean up both rooms. If the I don't know is in both rooms, which I think we'll see soon, you got to get him back together. And finally, you get him alone.